Next, we will look at the problem representation and variable type. Okay, so before we can proceed with different kind of optimization problem, so we need to understand about the problem representation and the type of variable that we are dealing with. So problem representation will refer to how a specific problem is formulated and expressed in a way that can be understood and solved using optimization technique. Okay, so this is very important for us to determine the problem representation that we are going to use in our problem, because the different problem might require the different problem representation. Okay, it includes defining the objective function, decision variables, constraint, and any problem-specific formulation. Problem representation focus on describing the problem characteristics, requirement, and constraint in a suitable format for optimization algorithm to operate. Okay, so we need to understand, or we need to know the type of variable that we are dealing with. Okay, the decision variable is unknown value that the optimization algorithm seeks to find in order to optimize the objective function. Okay, so this is the decision variable. So in the example of cylindrical tank that we discussed earlier, okay, the decision variables are the radius and the height of the tank. Okay, so again, decision variable is unknown value that the optimization algorithm seeks to find in order to optimize the objective function. Okay, types of variable. Okay, so we have a few types of variable. It can be in the continuous form, so it can take any real value within the given range. Okay, for example, as we discussed in the uh, tank design earlier, cylindrical tank design. So it can take any value between the minimum and maximum limit. So that is the continuous data or continuous variable. Then the second one is discrete, so limited to specific distinct value. Then we also have the permutation type, represent the order or arrangement of element. The binary variables, it's only take two values, normally 0 or 1. And the categorical variable, so limited to discrete option or categories. Okay, so we look at the definition of each category here. So for continuous variable, it can take any real value within the given range. Okay, for example, time. Okay, time, we can take any value in a certain decimal places and so on. The distance, temperature, and cost. So it can take any value. Okay, so this is the continuous variable, typically represented using real or floating point data types. So normally in our case, we are using the real data type. Then the discrete variable is a variable that can take on a finite set of distinct value. Okay, so this is the discrete variable. A variable that can take on a finite set of distinct value. For example, number of unit produced, the number of output in our production, for example, that is the discrete data. So number of vehicle, okay, number of bin used, and so on. So the the discrete variable normally represented using integer data type. So normally for discrete variable, we can divide into a few categories, but the most common one is the discrete variable using integer data. Okay, so the given example here are the integer data type, number of unit produced. So there is no decimal places in that particular number. Number of vehicle must be integer. Okay, so this is one of the discrete variable that utilize integer data. Then binary variable, a variable that can take on only two value, okay, normally 0 or 1. Okay, for example, yes or no decision, presence or absence of a feature, or on and off a state. So that is the binary variable. And for representation, typically represented using binary data type. Okay, in our optimization problem, it will be represented using binary data. Then permutation variable that represent the order or arrangement of a set of elements. For example, order of visiting cities in traveling salesman problem, sequence of tasks in scheduling problem. So that is the representation using permutation variable. So for the representation, typically represented using array or list of element in specific order. So this is how we represent the permutation variable. Permutation means a sequence of something, sequence of order. Okay, for example, if we have a set of job to be completed, job number 1 until job number 5. So which one we should process first? So that is involving the permutation variable. Then categorical or nominal variable, a variable that can take on a limited number of discrete option or categories. Okay, nominal variable, type of product, okay, employee roles, vehicle model, and so on. So this is the categorical variable. A type of product, product A and product B, employee role, role 1, 2, 3, and so on, vehicle model, model X, model Y, model Z. So this is a categorical variable. So for the representation using enumerated data types. Okay. So in our example, normally we are dealing with continuous variable, discrete variable, and permutation variable. That is the most commonly type of variable being used in optimization problem. Okay, for example here, again a spring example, a helical spring is designed to reduce the weight. So three variables are considered: coil diameter, D, coil wire diameter, small d, and number of coil, which is n, number of turn here, number of coil. Okay, so the detail of variable as follows. So for the diameter is between 0.05 to 2.0. Okay, the wire diameter 0.25 to 1.3, and n, which is number of coil or number of turn, in this problem is between 2 to 15. The number of coil is between 2 to 15. In this problem, the number of coil must be integer. So there is no continuous. This is not a continuous data. This is the integer data or the discrete data. So it only can take the integer value for the number of turn or number of coil. Okay, so this is one of the example. Vessel design, okay, to minimize total cost of materials, forming and welding process. Right, so design variable, we have a TS, which is the shell thickness, okay, the thickness of this cylindrical area. TH, head thickness, okay, the thickness of the head. R is the inner radius, okay, and L is the length of the cylinder. Okay, variable range, okay, for X1 and X2, okay, X1, which is shell thickness and head thickness, okay, it consists of a set of discrete variable, okay, which is 1 times 0.0625 until 99 times 0.0625. So in this example, the delta or the increment is 0.0625. Okay, so it cannot take any value, but it must consist of the increment with this value. Okay, so this is the discrete variable. And the second one, x3, x4, the inner radius and length of a cylindrical section are the discrete variable. Okay, discrete variable, so it only can take integer value. Okay, so between 10 and 200. So this is another example of problem representation. Consists of mixture between discrete variable and discrete integer variable.